Well, hello, everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. So I apologize if you were in here at the beginning and I played that intro twice. We had some connection issues. I think Restream's been having a little lag in it today. So I went ahead and replayed it a second time. I really appreciate everybody joining in. Tom Leck, glad to have you here with us. Hey, David Harrell, glad that you're with us, my friend, joining in from the Cincinnati area. So we've also got Wayne Lawrence. Hey, Wayne, thanks for joining us from Petro. Kendrick, hey, Kendrick, I haven't got that iPad Pro sent out with the conduit tech yet, but as soon as I get that shipped out, I'll make sure that Renee knows and get that picked up at the office. And everyone, let us know where you're joining in from. And so grateful to have you all with us today. We're joined today by Jeff Kukert from Copeland. How are you, my friend? Oh, I lost audio. Hold on. Oh, I bet it. Hold on a second. Hey, let's try it again.
Oh.
Yeah, there we go.
Awesome, Clifton. Great. I am doing well. Having a great day.
Yeah.
Excited.
Me too. It's been a great day. Had a conversation earlier in the day about, some of our R454B concerns and ways that we can get through that. Catherine, thanks for joining us. Yeah, you're right. Jeff is the man. When we first started having this conversation about who could come over and, have this compressor breakdown, we're like, Jeff's showing up. Like, all right, now we're going to really get somewhere here. I know, Kendrick. So glad to have you here with us. And if anyone has any questions along the way, we've got a lot of things that we can talk about and break down. Jeff is joining us from the Copeland Technical Training Facility. That's actually kind of where I got my start in all of this education. I don't even know if you knew this, Jeff. So when I came out of the field, so I got recruited. I had a recruiter reach out, right? So I was doing commercial refrigeration, and I don't know. Sometimes in life we get kind of plateaued, right? And I had a recruiter reach out and he's like, hey, I have an interesting opportunity for you that is actually in education, but it's not at a school, it's at a distributor. I'm like, what's that all about? And it ended up being, hey, but Murph, glad you're joining us from the shore. William Ramsey, glad that you're hanging out with us here today. So it was with Johnstone Supply, the Grimmy Group out of Cincinnati. And so I thought I'd give it a try, right? Get back to the industry. And one of the very first things that they did, and that would have been I think it was around 2018, was they sent me over to Copeland for classes. I mean, that's how old this shirt is. I mean, right?
That's awesome.
And on my counter in the background, it's always here. That was my compressor from my first teardown, right? So this thing has traveled with me everywhere. And that's what I tell everyone. Like, really, if you're going to learn how to work on compressors, semi-hermetics in particular, and scrolls, you need to understand how they work, right? The best way to do is break them down and learn from the manufacturer. And this is my first, right? So I spent a lot of time on Copeland 2Ds, 4Ds, a few 6Ds. I've actually got a 6D sitting over at Johnstone Supply that they want to do a class on sometime. I'm like, I bet I can wrangle in Copeland. We'll do that one as well. Yeah. Thanks for joining us in from Bristol University, William. So, Jeff, I've actually got one of mine here too. So this is one of my originals. So this thing has been around the block a bunch of times. And it's even missing some parts, but I know you're going to have all of them there today. And, a majority of our audience is going to be educators. And I always enjoy walking through like how to actually dive into compressors. How do they work? What happens when things are not working well? What's the consequences? And can we take a look at them? So after coming to the Copeland class, I incorporated in every one of my compressor trainings a teardown, at least to cut apart and take a look, right? To see what's inside. And so, we want to talk about today, especially for educators, ways to do these trainings in your own classroom, but break down the parts and understand what happens when things go bad. So absolutely. With mine, one of the things people always ask is, when you cut a scroll apart, is there a good place to start from? And looking at yours, I see that I've done a fairly decent job of getting in the right area. So I typically will work below my weld line, but above 100%. My indentations, which are the dimples that compress in and hold my upper bearing assembly for my rotor. And so that tends to be a good place for me.
Yep.
And if
Yep.
I've got a metal shop or if I got a bandsaw, it's a lot of
Mhm.
fun for students and
Yes.
technicians, especially at our contractor level. 'Cause contractors have so many of these. It's a perfect opportunity to tear them down and do training.
Ex-
So,
Yes, exactly.
Jeff, if we were coming over to Copeland and we were going to start learning about Copeland scrolls, where would we begin?
If we have so many resources online, so we have a online training that we can do that people can get to. Um, and really important for educators if they just Google Copeland educator resources.
Yep,
And we have different kits. We have scrolls that are already tore down that there's no sharp edges,
ready to go.
ready to go. So they can buy those online. But I always recommend when I used to teach at a college, I had the students all the time go in and tear apart the compressors.
Yeah,
So same thing that you just said. I have them cut right below. The important thing is I did a training about a month ago, and I was training at a large contractor, and I I the guy said that he has about 4 scrolls to tear apart, and I said, "Oh, that's great." I told him where to cut them apart. What I didn't ask him is if they are digital scrolls. So I have an
ooh,
example of a digital scroll, and they look. This one, the top is off a little bit,
right.
but when they cut below the welded seam, like you were talking about, they couldn't. This just rolled on the compressor. They couldn't do anything. And I went, "Oh shoot! I forgot to tell you." Now it's harder. So now I try to remember to tell people if there's a pipe going in the top of that compressor, what they need to do is cut about a 1/2 inch above the welded seam first. So we would have been up here, um,
Okay.
and then it's a lot easier. Then we can get into that. And usually, what I do is right where the discharge is, there's a piston, and I don't know if you can
Oh
see
yeah.
these holes.
Yep.
You can go through the discharge with a big screwdriver or something, and
Get
then
some
this
leverage.
part, yep, and this unscrews
Very
from
cool.
the fixed top scroll. Now we can take everything apart. Then, so after they cut the top part of the scroll, then we cut the bottom of the scroll, then everything can come apart. And then
So, could
there's,
you tell us a little bit about that digital? What makes the digital separate than just a standard scroll, say that just has the solid top?
yeah. So the digital scroll, what it does is our scroll sets, they all have compliance built in. So an axial compliance. So 1 millimeter, that top scroll will lift and it'll go radially. Also, just a little bit, if there's any little bit of liquid or debris that gets into that scroll set.
Yeah.
Well, when a digital compressor does the same type of thing, it lifts up that 1 millimeter for that compressor. So if it's a refrigeration compressor, it has a 20-second time frame. Okay. So if I wanted to run 50% capacity for 10 seconds, it's going to run normal. And then for 10 seconds, that scroll set's going to lift up. It's still moving around in there, but it's not doing any work. And then
It's
for
allowing
10
the
seconds,
gases to bypass.
exactly. And then it
Mm.
goes back down and whatever capacity we need. And digital scrolls will actually go from 10% capacity all the way up to 100% capacity. So they're using both refrigeration and air conditioning, except the air conditioning, the time frame is 15 seconds. So that you just have to, 7.5 seconds would be 50% capacity.
Okay, I gotcha. All
So
right.
yeah, so they're
Thank you.
awesome. Yeah.
Yeah, I had worked a lot with digital scrolls back in the old days of trying to use our 2D, 3D, and 4D compressors to give some variable capacity,
Yep.
and
Yep.
and that's what we would do. We would basically build
Yep.
timing to be able to control that unloader, and so
Yep.
that we had some variable capacity on the
Yep.
compressor. And so it
Yep.
completely makes sense. That's what we're doing. So we're raising that orbital so that we can allow that gas to
Yes.
bypass for moments of
Yep.
time.
Yeah.
Very
Yep.
cool.
Absolutely. So if we had a class of students, the most important thing is I want them to make sure that they dump the oil out first,
Yes.
right? So the school that I worked at, we had a plasma cutter,
Yep.
and you always want to especially want to make sure that they dump the oil out. But literally the students in less than 5 minutes could have that top of that compressor torn off. And then we can just start going in and taking apart things. Usually the scroll set on the top will have 3 or 4 of these little bolts. It's kind of a reverse Torx. It
Exactly.
is actually an E10 socket that you need.
Very
So
good point.
E, the letter E, 10. So that's what we need to take this apart. So once we have the top apart, then we can get into the scroll set. And now you can see inside, they should be all, like this is a brand new, well, it's not actually brand new, it was used, but it looks brand new.
Sure.
This is what they're supposed to look like, a scroll set, okay? And we can see what's going on inside that, whatever kind of compressor, but we're talking about scrolls today. What's going on, exactly. So there you have the fixed scroll, the orbiting scroll. The air conditioning ones have this suction funnel now. And that's probably, I don't know, year, 2 years. Time flies by, so I don't remember exactly when. But for air conditioning, to make that system more efficient, we take that suction gas right where the suction line comes in, goes right into the hole right there, and it brings it right into that scroll set to make it more efficient. Okay?
Absolutely. Put some additional cooling onto that upper portion.
Yep. And when you have this, if somebody wanted to go dig a little deeper, they can also cut the bottom of the compressor so they can get everything apart, which is nice. Because we want to look at all the surfaces and everything in there. So.
Exactly. I know on one of my shells, I did I had a variety of them. One of them I did a vertical cut so that you can just see the rotor inside, and then another one on the bottom so we can remove the shell. I really love the one that you have though from Copeland that's already ready to go.
Yeah.
I'll get a link set up and encourage everyone to go take a look at that, because it'll save you a lot of time. And you know, there's a lot of sharp edges. No matter how you cut these apart, if you do your own, there's a lot of cautionary components within that.
And especially for school, safety is priority number 1. We don't want to injure any students. So
exactly. Well, Jeff, mine is definitely an older one. This is a 2017 compressor.
Awesome.
It goes back to one of the things that you had mentioned the other day when we were talking about, I think Lenny had actually mentioned it, about the amount of compressors that come back with no fault found. So after leaving my Copeland training class, I was very curious myself. You know, how often does this occur? How often are compressors misdiagnosed? But if they are a problem, what does that look like? So we had an entire skid of compressors, all scroll, at the warehouse locally in Indianapolis. And I thought, okay, I'm going to start by doing an electrical diagnostics. I'm going to go around each of these compressors and see if I have any grounded out windings. And none of them did. Not a single compressor had an electrical component. I thought, okay, so I've got an entire skid of mechanical failures. And this was one of the first compressors I pulled out. And so today we're going to talk about some of the things that if we are opening up a compressor, what will we find? And you know, what could be some culprits, some concerns that cause them to fail. What is the most common issue that you see in doing compressor teardowns with a scroll?
Okay, so we do the compressor teardowns in Sydney, Ohio. So when we get we just randomly select different compressors. We don't take them all back right now. But we bring them back into Sydney, and the crew that goes through and does the teardown, unfortunately, the largest percentage of problems that they see is there's no problem.
Isn't that crazy?
That blows my mind. Yes.
Wow.
But the next biggest problem is overheating.
Oh, okay.
So when we overheat, and I don't have any overheated ones with me, unfortunately, but you would definitely, so this is called the muffler plate.
Yes.
So you would definitely see overheating in here. You'd see it sometimes, because when we overheat that compressor, a lot of times it washes, we don't have any oil lubrication.
Correct.
And instead of these surfaces being black, they will turn all silver. So this, you can obviously see the difference. When they're all silver like that, we've lost lubrication. And sometimes inside the scroll sets, you'll actually see it blue. So when you
Yes,
look in there, imagine how much heat that takes to turn one of these blue. It's that's crazy.
absolutely.
So
So is the bluing typically what we would even see on the inside? Because I know even with this one, I had some discoloration,
yep,
particularly
yep,
along my perimeters.
yes, exactly. Yep,
Okay.
yep,
Okay.
yep. So that's the most common problem we see in a scroll compressor. So you have to remember a scroll compressor is a refrigerant cooled compressor,
Mm-hmm.
right? And when we're talking about overheating, the most important thing that anybody out there can do is when they're looking at their gauges, they have their high side gauge and their low side gauge. All we have to do is get that to atmospheric pressure. But for easy math, we're going to just give that, turn it to 15. Okay.
Yep.
So whatever our pressure is, we add 15, we subtract or divide our or
Our
high
low
side
side
by the
from
low
high.
side.
Mm-hmm.
And yes, I'm sorry. And then we get a number. So the compression ratios that we are looking for, so we want for air conditioning 3 to 1. So whatever number you get, when you divide those, you'll get a number. So if it's 3.2, it's the compression ratio is 3.2, right? For medium temp, we want 5 to 1. And for low temp, we want 10 to 1. Okay. So that is the easy, even without taking a thermometer out, I can tell if my compressor is running hot by checking the compression ratio.
Exactly. So,
Yeah.
Tom, you actually mentioned a good point. So, this was a 2017. The reason I took this particular one off from the skid is because this was on a less than 1 year old. It would have been a Goodman Amana Daikin product at the time, and it was brought back under warranty. And so we were curious, what does that look like? And so, Jeff, am I seeing bluing across the edges, the facial edges of this particular scroll?
Yeah. That one has started to, looks like it has a little bit of overheat.
Yes.
Definitely I've seen much worse, but
Yeah.
that's definitely, and you can see the silver. We shouldn't see silver like that in that scroll either. So yep,
Exactly. And so when we
yep,
started looking at this one, this was a compressor brought back under warranty from a
yeah,
recently installed unit, and it was very clear that it wasn't a compressor failure. It
yep,
was an
yep,
operating condition that was noted by the technician, and then they
yeah,
assumed it was a compressor concern. And
yep,
in all actuality, that's what we'd see here. We've seen a compressor that was running hot, either from
yep,
excessively high superheat. There's a
yep,
variety of things that could
yep,
have created that. But yeah, Tom,
yep.
you're right. That was a 2017 compressor torn apart in 2018 as a warranty item that was realized after tearing it apart that there was no reason for that compressor to have been warranted. It was an operational condition.
Yep, yep, that
Sadly.
happens all the time. And
Yeah.
I think a lot of compressors, when they get overheated and the motor protector trips, we'll have a technician go there. They're ohming out that compressor, and it shows that we have an open winding. They go, they get a new compressor without even seeing, well, how hot is that compressor? I always try to tell people, feel the top of that compressor. If it is hot, we have to let that cool down, right? So when we cool down that compressor, that motor protector will reset itself. Or even the person that's coming to replace the compressor, if they would just at that time ohm out that compressor, more than likely it would be just fine. And then it would
Exactly.
just work and there'd be no problem.
Well, let's talk
So,
about that just for a minute for those that are not familiar with what we're discussing. So, we may typically think of our electrical terminals going directly from the compressor to the motor windings, but we actually embed a thermal cutout within the winding structure of our rotor. And that's such a common concern in the industry. Remember, when I had that entire skid of compressors, I pulled the warranty file, and many of them showed that they had electrical failures.
yep,
And realistically, probably what was happening was the same thing as this. It
yep,
wasn't being ran properly. It wasn't operating as it was supposed to. It overheated and had a thermal overload open. And if it would have been cooled down for a period of time, the compressor probably would have restarted no problem.
yeah, exactly. Yep, yep,
Okay.
absolutely.
Yeah, Tom,
And
that's great to hear that you got a few of them out there on your own. I highly encourage it for any instructor to have, a variety of different
yeah,
compressors around. I just love working on a scroll because of the simplicity of it.
yeah,
It is so easy to get
yep,
into and have everything right in front of you in
yep,
just no time at all. And it's a very clear understanding of what happens inside of them.
yep, absolutely. Yeah, it's very easy to see when we have overheating, when you see the discolorations, and um, when things are starting to turn silver and stuff like that. Other things can actually make it turn silver too, but we'll get to that in a second. So,
Okay. One of the questions that is a comment, but it's actually kind of a question that Tom had brought up on some of the compressors that they have copper plating that
oh
actually
yeah,
occurs inside of the system. What's actually going on there if we see
oh
copper plating building up within our pump assembly?
yeah. So what happens is um, two things can be a problem in that system that cause copper plating. One is they did not evacuate the system properly in the beginning. So they
Yeah,
didn't get all the moisture out of that
moisture.
system. Yep. The other is if we got a leak later on and we had moisture come into that system. Okay. But moisture is the big problem. So with POE oil, when we introduce moisture into that POE oil,
Hmm.
it's going to turn to acid. And then that acid is etching away at all of our copper. And then it goes to the hottest surfaces. So any bearing surfaces, usually, that's where we're going to see copper plating. And when I do I've done probably thousands of teardowns, and that is a very common thing that I see is copper plating, because I would say majority of people are not evacuating properly. So when we're educating students, we really need to push. We need to do this the way the manufacturers want us to do this, and they're all going to tell you to make sure we, whatever it says in their manual, that's how we want to evacuate that system and get all that moisture and contaminants out of that system. So
Absolutely. I see a lot of that out there in the field of people who have taken compressors apart and see the copper plating and wonder what's happening. Is my windings dissolving? There's so many different items that you'll
yep,
see on social media, but it's exactly it. It really comes back down to contamination within the system from improper installation. And it's clear
yep,
to see. Where does the copper
yeah,
come from? It comes from the copper. It comes
yeah,
from our lines.
exactly,
That's our
yep,
copper coil.
yep, exactly, 100%. So that's our
Yeah.
problem. Yeah, definitely. So it's
Yeah,
very funny.
Murph, this is a great point. So, if you are a contractor, you've got your supply of compressors. If you are a school and you're buying
Hmm.
new ones from Copeland, but you want additional ones in your
Yeah,
classroom, work with your local distributors.
yeah,
Many distributors will scrap scratch and dent units or
hmm,
warranty units that
hmm,
are perfectly available, just like this one was,
yep, yep.
to be used in the classroom.
Yeah, those distributors want to work with local schools, definitely. So because
Exactly.
they can hire people also from, right? Distributors need people just like we need people everywhere in this industry. So yeah,
Indeed. All right, so most of our compressors, or a significant amount, no fault found. Once we
yep,
get past that, we are going to find overheating, which is
overheating.
going to
Yep,
show some polishing. It's going to show some bluing. We have
yep,
copper that we'll see from moisture in the
yep,
system. What
yep.
else are things we can be looking for in a teardown?
With a refrigerant cooled compressor, the next most common thing would be we have flooded starts. Okay. So when the compressor is off, that refrigerant will migrate back out to the compressor. And when that compressor starts, is almost like an explosion inside. And then we'll have just sporadic problems. And you'll see in different bearing surfaces, that's where our problem is. So you'll be able to see problem. A lot of the bearings will be good. Then you'll see a bearing that's really, really bad. That's usually something like that. Or in in this area, I'm going to grab we have this drive bearing. So a
Yes.
lot of times with the flooded starts, this drive bearing is the most common part in this area that we find the problems. Okay.
Okay.
So it's a last bearing surface usually that we're going to see that the problem is.
Will it be scarring or will it be like golding or just excessive polished wear?
You little bit of everything. So
Okay.
Yeah. So this one, there's a lot of that. This is literally scarred. I can feel there's a ridge here, and you probably can't see it in the camera here, but you can see the galling. Just the cool thing is, if anybody gets one of these scroll sets, it's fun to show people how these actually work.
Mm-hmm.
Because a scroll, when you have the scroll inside the top scroll, the bottom one is the one that orbits, right? And we need that Oldham coupling that takes the orbiting, the main motion of the whole crankshaft to turn, the turning motion into an orbiting motion. Okay, and
Uh-huh.
it fits in these little grooves. And when this is moving, what'll happen is it just makes these little circles, and you can actually see it
Little
in
swirls.
these. Yes, exactly. Yep.
And
So
so that's
this
been
one,
from a lack of lubrication.
yep. And that's
Okay.
what happened to this actual scroll set. And you probably can't tell, but this bearing surface, I don't know if you can
Oh, there's a lot of
hear
slop in
that.
it. Yeah.
Yeah, it's all sloppy. It should be nice and tight, but this one, it's just all sloppy in there. So that's what will happen with flooded starts. Okay.
Excellent.
So that's the most, with refrigerant cooled compressors, that's probably the most big problem thing. If we have a lot of liquid come in, and we literally, you'll have liquid filled up inside of the whole cavity of this compressor. And when it starts, it's just going to come right into that scroll set. And then it's going to look like this. There's no scroll set on there.
Oh
It
yeah,
literally
it's like
broke
it's gone.
right off. Yes. So I'm going to grab this other one. That's what it should look like. So that's a big difference, right?
Yeah, no kidding. Yeah, the
So,
video qualities. I'm gonna try to change angles here and see if it brings a higher quality in for that or not. I don't know that it will. We just momentarily lost some of our video feed, but yeah, I can see that, and I'll
oh,
overlay some in the post edit as well. Yeah, it's just
okay,
completely
good.
gone.
Yeah. So literally that scroll set will completely break. And this one, you can see it also very easy.
Sure.
Um, that will happen. That's called slugging. Okay. So the other thing that we could have happen, but it's not as common with scroll compressors because they're refrigerant cooled, is flood back.
Okay.
Okay. Now, flood back is when we've lost control of our evaporator, right? We don't have any superheat left. We're getting little liquid droplets back into our compressor. And if they're just really little liquid droplets, that's where we have our compliance, our axial and our radial compliance, and it'll separate that scroll set and wash it out and go back into the whole cavity of that compressor. But when there's usually it will vaporize a little bit of liquid before it gets into the scroll set,
Sure.
unless this is that suction funnel. Unless we have a suction funnel on here, if somebody's putting say they're charging their system and they
Yeah.
just put a
Introduce liquid in.
whole bunch of liquid into the suction line, that's liquid right now is going right into my scroll set, and I've seen these break.
Sure.
So we have to be really careful. We want to make sure when we're charging a system, if we have to top off the system,
Hmm.
that before, a blended refrigerant, obviously, we have to have it coming out as a liquid out of our tank. But we want that refrigerant to be a vapor before it gets to our suction line, right? So that's the most important thing, is don't just keep adding liquid into the suction line, because that will eventually kill our compressor. And it can just destroy it can take life out, or it can slug the compressor and just kill it.
So using things like a molecular expander, using things that will
Yes.
help take our
Yep.
liquid, put it into a vapor state
Yep.
before we
Yep.
introduce it into the compressor.
Yeah. And all it is a little orifice, and there's all kinds of different manufacturers that make them.
You bet.
Yeah.
So
Yep.
recommended for all scroll compressors if we're charging with liquid.
Yes. Yep.
Okay.
When we're dealing with refrigeration, there's so many different things that we can do, and if a system has has a receiver and a king valve. We can do different things to bring that refrigerant into that system and suck it out of a tank. So it's a little
Sure.
different with refrigeration than air conditioning.
Exactly.
But still, in the refrigeration, if they're introducing it on the suction side, we want to make sure to bring it in to that system as a vapor. So yeah,
Very, very cool.
that's
Anybody
that's
have
for
any
sure.
questions yet? We've got a lot of people out here hanging out with us. We encourage questions along the way. When you got a chance to ask the professional at the factory, in the facility, breaking
Yes.
down compressors. Now's the time.
I wanted to show, so when we get these compressors back to, and we do the teardowns,
Yeah.
so this is an example of a compressor. Everybody can see that rip up here.
Mm-hmm.
So what they do is they'll take all the scroll set, they take everything apart, they analyze everything, they write down everything, what happened to that compressor, or if nothing happened to that compressor. Even if nothing happens to the compressor, you know, when it came in, it was no fault found and it
Mm-hmm.
worked, they still take everything apart. Okay. So then they bring it to a different area and then they put it in a machine. They cut off with a bandsaw the
Yep.
bottom of that scroll. Okay. Then they put it in the machine and it rips that half, it's probably about a ½ inch
Sure.
wide strip up here. Push another button and it presses out the stator. So here's this one. These are
Yes.
heavy.
Yeah.
But here's our stator. So you can see they pop that out. But I just wanted to show this is what it looks like from the factory when we do it. It's normally not going to look like that when a contractor, a teacher, instructor does it in wherever they're doing it. So it's
Absolutely.
pretty
Yeah.
cool to see.
Wayne, yeah, we're so grateful to have our OEM instructors hanging out with us, diving into these trainings firsthand. You know, it's one thing to learn from the field, like most of us do. It's a different
Yeah.
experience when you're learning with the technical trainers that build the equipment, that actually work with this stuff every day and do these compressor tear outs and tear downs to be able to see what actually happened to them.
Yeah. Yeah.
Very cool.
It's amazing. Even me out, doing training constantly all year long. Every time I'm back in Sydney, just learning new things because we're constantly come up with new things. And it's just amazing to me how many smart people we have here. And I can just, ask questions to anybody. Hey, why did we change this? Or what's going on here? It's so awesome to be able to know that and get that firsthand knowledge to be able to share with people. That's why we want to talk to, the OEMs, right? Because they're the ones that are going through it. So
Exactly. Now, with your teardown classes, like, do you offer those for instructors or for contractors to be able to participate in?
yes, I have a lot of instructors that go to my different classes. So on our website, also under educational resources, you will see where we are. Some of the classes I do, they close. So certain wholesalers, for instance, will just say, I want to just look for my audience. I want certain people to come to my training.
Right.
Other ones will invite anybody. And I might be in North Carolina and I have somebody from Washington State flying into North Carolina to go to my training.
Yeah.
So I have people from all over and I go all over. So I'm all over the country. So it's just whichever wholesalers put it on our list and I just show up. So it's awesome.
I did put that link into the chat. That is to get over to the the training and educator resources. Anyone's curious to check that out.
Yeah.
All right. So as we're tearing apart compressors, we start with, like, say, these earlier generations that don't have the pickup off the suction side. We move into the new generations. It's got the suction pickup channel.
Yep.
And we got our digital unloader. What about, like, with a two-stage? What do we actually see within a compressor for a two-stage operation?
With two-stage compressors, what we would see on the side of the fixed scroll here somewhere, there's a little three-way valve. There used to be a little solenoid that's been gone for quite a while, but now there's a little three-way valve. And the two-stage modulating compressors are one of my favorite because they're so simple, right? So whenever all I need for a two-stage compressor is a Y1 and a Y2. So I need two 24-volt signals. When I hit Y1, what happens is I energize my contactor. Then I have power that goes to my compressor and it turns on. And what happens is in my scroll set, there would be some holes on both sides in the inside of this.
Mm-hmm.
So if you can imagine, it still brings in the refrigerant the same way, but it bypasses part of that refrigerant back into the body of that compressor.
Okay.
The rest of it is what's getting compressed. Okay. So for many, many years, the two-stage was always, the first stage is 67% capacity.
Mm-hmm.
Second stage is 100% capacity. Now for probably a few years now, it's 65% is the first stage, and then 100% is the second stage. So when we have Y2 kick in, there would be another spot, another connection on the side of the compressor, okay? And what it is, it's a little rectifier. So I have just normal 24 volts AC that sends a signal to this rectifier. Then that rectifier sends 24 volts DC to my three-way valve. That then, when it goes to second stage, it closes off those little holes. Now it just runs like normal. So if you ever
100%.
had something fail, it would always just run on 67% or 65% capacity.
Sure. Absolutely.
Yeah. Yeah, they're very simple. You can replace that rectifier if it ever went bad. But they're, everything in our compressors, we have it in there to run for the life of the compressor. So everything should last for years and years and years. And we go through a lot of extensive testing. We have just beautiful, beautiful lab facility in Sydney here.
Mm-hmm.
So, and the cool thing about our labs where they're doing all the testing and everything, it has windows so we can actually see what the people are testing. Okay. So we can see, are they putting a bunch of liquid into that compressor? Are they, it's just so funny how they kind of beat up compressors.
Yeah.
But they're trying to mimic what these compressors will really do when they get into the real world, right? So
yeah, absolutely. Yeah. We always talk about how forgiving a scroll compressor is, which they are to a very significant amount.
Yes.
But it really, it's more important to understand that they're operating properly, right?
Yes.
That we're getting our actual, superheat within range back to the compressor, that it is actually, flowing properly.
Yep.
So Tom had an interesting comment I wanted to bring here. When overheated, the ring will warp. Were you talking about the Oldham ring, Tom?
Or was he talking about the floating seal, this part?
I wonder. Could you tell us a little bit about that floating seal?
Yes. So this one has the floating seal. This is what it looks like when it's in the top or fixed scroll. Okay. So when people are taking these apart, usually what I use is two little tiny screwdrivers, and this will pull out of here. This is what it should look like. Okay. On the one side, it's cast iron. On the other side, it's aluminum. And in the middle is that green gasket material. So it's in there very, very tight. Okay. But when these get overheated, that's a great point. I forgot to bring that up. These will get all discolored also. And you'll see this will get worn and it doesn't seal properly. Okay. And this is also one of our safety mechanisms in our compressor. Okay. So for example, on a refrigeration compressor, if our compression ratio got above 26 to 1, that floating seal will go off center. Okay. So I'm going to just show you that floating seal. I'm going to grab, this is our muffler plate. And when you look inside that muffler plate, you can see that flat, and to me, it looks like a big washer.
Sure.
Right. So that big flat surface right here. And if you look at the top of our floating seal, there's a ridge where it sticks up. So that ridge, when a scroll compressor, for a Copeland scroll compressor, when it starts, it lifts up that whole floating seal to the bottom of the muffler plate. Okay. So you'd have a muffler plate right above that. That floating seal lifts up because there is a cavity. And this one, you can see the cavity with the floating seal out of there. it gets pressurized in that cavity, and that's what is pushing it up. Okay. Now, when my compressor turns off, now I have high pressure, and it pressurizes down on that cavity. I don't know if we can see this or not. Let me see where it is, first of all. There you can kind of see there's a hole.
Yeah.
Where is it? Right there.
Yep.
That hole goes inside of the cavity of the scroll set. So it bleeds that pressure through, and what happens is my floating seal sinks down again,
Okay.
and my high pressure that's above my muffler plate will go down into my low pressure inside that compressor. So now my pressures are equalized.
You bet.
And what that does for us is now I don't need a whole lot of starting torque to get my compressor to start to turn.
Actually fire
Okay?
up. You bet.
Yes. Yep. And then as soon as it turns again, now through that little hole, as soon as it starts to compress, I get pressure that pushes that floating seal up against that muffler plate again. But when that's worn, when we overheat it, or if it starts to go off center in there,
Yeah.
then we run into problems. So it'll rip that gasket material in there.
Yep.
And it'll usually the gasket will turn black also. It just gets all nasty. So yeah.
Okay.
Great point. I'm glad he brought that up because I forgot to mention that. So yeah.
I tell you what, maybe this is an opportunity. Would you like to walk me through how to actually remove this? You say I can do it with just a couple screwdrivers?
Yes, love to. So grab a couple little, like the thermostat screwdrivers.
Let's do that one, and then I got a okay.
Yep. So just kind of drive in there a little bit, and you'll see it start to lift up, and it just it takes a little bit of time. You just have to keep working on it, going around in a circle, and then it'll pull up. Yep. Does it
Look at that.
feel like it's moving a little bit?
Oh yeah, it's moving.
Good.
We're moving right along here.
Awesome.
Not quite there yet. We're going to get there.
It's amazing how stuck it is, isn't it?
Yeah.
So that gasket material really holds it in there.
It sure does. All right. So I was able to walk around just like you were saying, and I should. Yeah.
Yeah. There you go.
Be able to remove.
Yep. And there it is. Oh, look at the rust in there.
Look at that bad boy. Yeah, that is interesting. So I don't know.
And there's that hole I was talking about. So yeah.
Very good. Yeah. So I don't know if that was, I would assume that was moisture from operation, and that it's because I'd never removed that seal. So that's the first time it's actually been out of there.
Wow. Yeah. That's crazy.
All right.
Yep.
So we definitely had some moisture.
Yep. I've actually taken apart compressors and seen water in it. So
really,
it's crazy. Yeah. Especially around the coasts.
Yeah.
So,
interesting.
Or if it's a chiller, with a water cooled chiller or chiller barrel or whatever that leaks, something like that. But,
sure. This is Wayne. This is a good question. Wayne was asking, can we go over a proper procedure for like a warranty compressor change out? If someone was removing a compressor for potential warranty, what is a proper procedure for doing that?
Love it. Okay, so I'm going to grab the top of this compressor because you can see this is the discharge right here.
Yes.
This is one of the most important things. So we're going to have our discharge line hooked into here. Our suction line goes into the suction port, right? A lot of contractors out there will want to heat up this and pull that off. If you ask any manufacturer, they're going to tell you don't do that. Now, that's not a good practice. We want to cut out any component, right? So try to cut it out. And then once you cut it out, you can heat this up and pull that out. But we want to be careful what's inside that system.
Sure.
Especially if we have an A2L or an A3 refrigerant in there, we have to be really careful, right? Absolutely. So we were cut our line out. It's easiest to cut it out, give us a little bit of room, heat it up, pull that out, and then put that plug that you just have in that warranty compressor, plug it back in here, okay? Because if we have to have it sent back, we need a plug in there. The other thing, so you can see it's kind of hard. You can obviously see it's copper colored right here.
Yeah.
So for years and years, when we had compressors, our ports or stubs that came out of the compressor were copper, and then they would get shipped somewhere. And then I'm sure people that have been doing this for years know this. They would come, and then this is not circular anymore. I can't get a pipe in there. So then I had to get something, and I'd have to make it round, and I had to get my pipe in there. And it's just a pain, right? So then what we started to do is make this port a steel tube, okay? And then it's copper plated, okay? So it has copper on the inside and outside, okay? So we can still use our normal practices, but we don't want to, when we have that new compressor we're putting in there, you don't want to have too much heat, because literally that copper that's in here will go away.
Exactly.
Okay. And then we have a steel port on here and a copper pipe. So when we have dissimilar metals, now we have to use silver solder. Okay. So you can use like 45% silver solder and do it that way. But it's that's a lot harder. We'll just say that. So we don't want to do that.
Okay.
So that's one of the most important. So if I have my existing compressor, I cut out my pipes, remove my old compressor, and most of all, any starting components, the contactor, the relays, whatever it is, I want to replace all those parts, right? And put new parts into that, because that could have caused the failure of that compressor, right?
Sure.
And so we want to put all new parts in. Then we put the new compressor, we pipe it all in. And then what we want to do is what Copeland recommends when we're charging that system up, once you evacuate everything and you got everything all set, everything's down, so all the moisture and contaminants are out of the system, we're adding refrigerant. Copeland wants you to add that refrigerant to the high side of the system, okay? And then it'll go through the high side into the low side. We do want to make sure we have enough refrigerant and pressure in the low side when this compressor starts.
Sure.
Okay. And go through and get all the refrigerant we can until we can't get any more, whatever we're looking for the amount of refrigerant. Once we get this compressor running, we want to make sure we have the right voltage, right? Look on the compressor, see what the voltage should be. Check to make sure we have the right voltage. Then we want to check the amp draw, okay? Now, on all of our compressors, they have barcodes. So I can scan a barcode for the model, barcode for the serial, or we have a QR code right here. I can go into Copeland Mobile, okay? Copeland Mobile is any technician's best friend. It will help troubleshoot, especially students. It'll help them to advance their career a lot quicker and diagnose problems quicker and more accurately, right? So then we're going to have our ammeter. We're going to check our amps. We're going to go on to Copeland Mobile, and you can go into performance, and then you can actually go into Copeland Mobile and look at, you can go into dynamic and put your conditions. So you go to your pressures, you go to a PT chart, you put, okay, my condensing temp is this, my evaporator temp is this. Then I hit the button and it tells me what my amp draw should be. Okay. The number on here that says amps is not what we want to look at. Is that most people think they're just looking at the number on this. We want to go to Copeland Mobile and look at whatever our conditions are and see if our amp draw is within the range that it's supposed to be. Okay, so as soon as our conditions change, our amp draw is going to change. So our pressures change, our amp draw is changing, our mass flow is changing, our capacity is changing, our efficiency is changing. Everything is changing every time we change any pressures, any conditions that our system is going through, if that makes sense. So we want to make sure that new compressor is going to be working the way it should, and it's going to have a nice long life. And we want to make sure there's nothing else wrong in that system. And we have to remember, when we're charging a unit, we have to make sure, do we have the right CFM going across our evaporator coil? Is everything clean? Hopefully they've cleaned the condenser, they've cleaned make sure the evaporator's clean, they have a new filter, all that stuff when we're talking about air conditioning. But we want to go through all that stuff to make sure everything's good, right? Before we start changing things. if my airflow was off and I
Everything's
charged
off.
that to what I thought, I reset that airflow, everything's still going to be off. It's going to be off again. I have to go back and do that whole job again. Right.
Yeah.
So that's
Yeah.
going to be a problem. And hopefully all of our, instructors are explaining that to students, and, so we can get that to the new people coming into this industry. So we can get a lot of things diagnosed correctly. Right.
I agree.
Our purpose on our training is to make sure that we don't get so many compressors back that have no fault found. Right. We want to make sure that compressors are diagnosed correctly and quickly. That's what our app helps you out with. And the cool thing that we just came out with our app is we have something called Scout. Okay. So as soon as you open up the app, it says Scout on there, and you can click there and you can do voice to talk or voice to text. There we go. Voice to talk, voice to text. So you can just say, what's my pressure supposed to be, or what's my amp draw supposed to be on this compressor, whatever it is. Scout can tell you where parts are. They can help you diagnose things. It's kind of your one-stop shop, and it uses AI to look at all of Copeland's data. Okay, we have a lot of data that we've been making compressors for a long time. If you can imagine how much data we've accumulated to help our compressors last a long time, that is all input inside of our apps, and Scout's going to continually to get better and better and better. So excited about that. I could talk about that for hours by itself, but
I
I
think we
want to make
should
sure people
sometime.
understand. Yes,
Yeah,
exactly.
it's a phenomenal resource. That's why I wanted to bring this up. Not only is
Awesome.
it mobile applications, there is the browser-based version
Yep.
of this that is absolutely perfect for the classroom. You can bring it up on the
Exactly.
TV, big screen. And
Yep.
so I threw the link
Yep.
to the Copeland mobile
Awesome.
so that you can grab that,
Yep.
and you've got to go through it. I was just
Yeah.
introduced to Scout a couple weeks ago when we were doing this heat pump
Yeah.
installation,
Yeah.
and
Yeah.
for like a nerd like me that loves service bulletins, man, there is
Yep.
no better
Everything's in there,
way.
man.
It's all here.
Yep. Yep.
Yeah.
There's
So
so many great things in there. And that's what I was going to say is anybody that works with a computer, and especially when you're teaching people, it's
yes,
so much easier to do the desktop version. And it's wonderful. Yeah.
I
So,
agree. Every classroom, every instructor on here should have it in the
yep.
classroom as a
Yep.
reference tool.
Absolutely. 100%. Yep.
I did have
Yes.
one question. We got about 5 minutes left, and this is
Yeah.
one. So I'm one of these old dogs teaching new tricks, and
Yep.
it's something that I need to get better at myself. Since we have moved to dissimilar metal service ports, not just on compressors, but
Yep.
on our outdoor units, a variety of different components,
Yeah. Yeah.
is it an acceptable practice to use flux, and how would we properly use flux when connecting to a compressor?
Yes. You can. Whenever we're using flux, we have to be careful,
Yes.
right? Anytime. We don't want to use too much flux. So when we are using flux, we want to put it on the male end of the pipe, right? We want to make sure, obviously, the inside the compressor is all clean, that connection. But on the male end of the pipe, that's where we're putting our flux, and we put it in. We just need enough. We don't need it to be globbed on there, and we don't want to have too much. And literally, when you press your pipe in there, if you have excess, it's best just to wipe that
Get
off.
rid of it.
Yes, and then you can heat it up, and then you can do your soldering. Yeah.
Yeah. So I know in the
Yep.
classrooms, that's a fantastic thing to introduce because many of us
Yep.
as educators came from the field. A
Yep.
lot of us came from the time when they were all solid copper stubs, not realizing that there
Yes.
have been these transitions. And it's
Yes.
very important to teach it in the classroom of,
Yeah.
how to respond. Because if we're
Yeah.
teaching the practices of using heat until it's cherry red, that doesn't apply on metal, on steel. So you'll find out real
Exactly.
fast that
Yeah.
plating disappears.
Yeah. Exactly. Oops.
Yeah, it's like, uh-oh,
We
now what
don't
I
want to
do?
lose
Well,
our copper plating will disappear, so we don't want that. Yes.
exactly. So if you're
Yeah.
not already introducing
Yeah.
that as a procedure, it's
Yeah.
something to look at as part
Yeah.
of your best practices in the classroom.
Yeah. I do want to mention one of the other common things that we see, and literally I just did a class today and we took apart some compressors. All of them had dye in there.
Oh, Yes.
Okay. I would say probably of my compressors I take apart constantly wherever I am in the country, I would say it's above 90% of these compressors have dye in there.
Really?
Okay. Yes. And it's crazy. So Copeland, if you go into Copeland Mobile, and then you can go to AE Bulletins, it talks about refrigerants under AE Bulletins. You click that, and there's a bulletin number 9311. Okay. In that bulletin, in the back of it, it tells you these are all the things that can be in a refrigeration system. And we had a company called Spectronics that came to us and said, can you test our product in your compressors? And we said, yeah, absolutely. We did that. And everything went fine as long as they use the correct amount of dye.
Right.
Okay. So Spectronics is the only dye that in a warranty situation that we will allow.
Okay.
Okay. If it is the right amount. So the right amount is I have to use a UV light to see if there's dye in there. Okay. If that refrigerant oil, I should say, turns green, if you look like it and it looks like antifreeze, that's too much dye. Okay. Too much dye is not a good thing.
No.
No. So we have to be careful with that. So I just wanted to talk about contaminants, and that seems to be kind of a growing problem that we see all over the place. So,
Yeah, I've wondered about that. I used to see a
yep.
lot of it in commercial refrigeration. I had a grocery store I went to one time that, I had walked in because I've just one of the practices I did because a lot of the older systems that I worked on had some dye, and I walked into one compressor room that had obviously had a line rupture, a valve gasket blow, something, and the entire room was green. So you'd never have the opportunity to find a leak in this scenario. So use moderately and as specified.
Yes, exactly. Yep. 100%. Yeah.
Very cool. All right. Awesome. Well, we got about a minute or so left. If anyone has any last minute questions, we'd love for you to let us know. Jeff, what is a good way that we can connect with Copeland to learn more? I know I've got the Copeland address I'll throw in here for that'll start everything at Copeland.com.
Just Copeland.com. Literally everything we have is under Copeland.com. And they revamped the website and it's done very, very well now. And it's really easy to find all the different products and all the different materials you're looking for, all that different stuff. And literally on our phones with Copeland Mobile, there's so much information in there too. So, but yeah, if they want to communicate with educational services or anything, everything's under Copeland.com. So, yeah.
Fantastic. All right, I don't have any other questions. Looks like we've covered everything very well for everyone. I encourage you all to download the Copeland mobile app, get that on your devices in the classroom, grab the Copeland mobile that can be used for the PC. There's tons of information, and get your butts in one of these seats. It's one of the best classes. It has meant so much to me. I said, I've had my souvenir, and I think it was 18 that actually went to that class. And that goes on, it's been on every desk that I've been at since then. And it just, it changed the way I looked at compressors. I had worked on many through my life, but I didn't understand them in this way.
We've been doing our Copeland cost class for so many years. I mean, years and years and years and years. And still today, that's probably everybody's favorite class. That's my favorite class to teach, definitely.
Yeah, so, I absolutely agree. Here's a great question, and I know it's going to vary, so this is kind of a loaded question, but I'm going to bring it up anyhow, just as a ballpark.
Yeah.
In air conditioning, because it's going to be different between air conditioning refrigeration applications. So, Osneil, if we're talking about residential applications, single stage, potentially in two stage, any ballpark superheats or any specifications that are within the Copeland range?
Yeah. So almost all of our compressors want 20 degrees of superheat at our compressor.
Okay.
Okay. So that's both air conditioning and refrigeration.
Aha.
There are a few, like we have low temp CO2 compressors. They want 36 degrees, which seems like a weird number to me, but I don't know. Smart people came up with it, so we're going to go with it. I've looked at one of my classes. We were looking up a R290 compressor,
Yeah.
And that one wanted 36 degrees of superheat. So I would
Intriguing.
say most of them are going to be 20 degrees.
Yeah.
But when you're in Copeland Mobile, you can go to the application engineering bulletin for that compressor,
Yep.
and it will say in the application engineering bulletin exactly what it's supposed to be. But
There you
for the most part, I say 20 degrees, we're going to be safe. We want to make sure we don't get any flood back coming back to that compressor.
That's exactly
So, yeah.
right.
Yep.
Your video feed is coming through really well. Could you possibly show us the scroll plate that was affected by a liquid refrigerant that is no longer?
Yes. This one.
Absolutely.
You can see how silver it is
Yes.
compared. It should be this color.
Okay.
Okay. So you can see it's grooves in here. This main bearing its surface is all worn out. Yeah, it's in rough shape. This should have parts that protrude from this, but in my travels it broke. It should look
Sure.
like this, by the way. But yeah.
Yeah. Did you have the scroll that actually had its veins broken off?
Yep. Somewhere. I have a lot of them.
Yeah. There we go. Now we got a
So
good closer picture. Oh, that's perfect.
this is the fixed, and this is the orbiting scroll
Wow.
right here. So yeah.
Unbelievable.
I have seen many of these when they get a slug of liquid in there or a slug of oil.
Sure.
Yep.
Okay.
It can be nasty. Yeah.
All right. Well, Jeff, we sure appreciate you so much. We're thankful to have Copeland
Awesome.
as a training partner, bring in firsthand education to the industry. Definitely get over there, take a look at copeland.com, grab that Copeland mobile app, and we will see you all again next week. Actually, you
Awesome.
won't. You'll kind of
Oh.
see me. I'm going to be on vacation next week, but I've got this fantastic video. It's a behind the scenes video that we put together from the Johnson Controls JDAC facility behind the scenes.
Oh,
So we're going to bring you
yes.
into a once in a lifetime opportunity to see what happens behind closed doors. So I will see you all kinda next week on Did You Know, the ESCO HVAC show. Bye, everybody.
Thanks, everyone.